at the beginning to introduce you to what we're going to do anyway, so that will give people a bit more time to trickle in. So, hello everyone, my name is Eike, I'm a data scientist with Eliiza, and I'm going to talk to you today about concept drift. And here's how I'm going to do that. First, we'll talk about what concept drift is, and also, of course, what it isn't. And then I'll have hopefully eventually have a conversation with you, but then I'll have a little rant about why we should care. I think it's important, and I think it affects everyone more than you might think. And for the technically minded, the probably most interesting part is what we can do about concept drift. And if you think I've said anything wrong or might have forgotten anything, we have a Q&A section at the end where you can pepper us with all questions. But to start, a bit loosely, I want to know what you think concept drift is, what your understanding of concept drift is. So these two are actual movies. They really exist. And only one of them is actually symbolizes, if you will, concept drift in a way. And I would like to know, if you use a chat, just type your answer, which one of these do you think is concept drift and why? I'll just give you 10 seconds to quickly type your answer. The cool thing is we'll do this again later at the end of the talk, and then you can compare yours and other people's understanding about concept drift and see whether you might have already known what concept drift is or whether your understanding has changed. And I'll give you 10 seconds to type a few answers in the chat. I can't see the chat right now, but I'll have a look in the Q&A at the end. Okay, and with that, we'll carry on. Concept drift sounds like something that's perfectly self-explanatory, right? I mean, it's a concept that's drifting. That does what it says. But that isn't actually all that self-explanatory, because what is the concept and where is it drifting? The important thing to know and realize about concept drift is that when you're thinking about concept drift in terms of machine learning, concept drift happens outside your model. It's not something that your model does. It's not something that, it's not something that your machine does. It's something that the world does, and it does it all the time. And concept drift you can think about as the material fatigue of information. The moment you put your information into a model, and the moment you stop the flow of information by saying, this is it, I'm writing this down, that is when your information starts decaying. That is when when the validity of your model starts going down because you're no longer updating it. So I'll give you an example. Let's say you're one of those Melbourne CBD coffee owners who, of course, has a dedicated data scientist on the team who also happens to make great coffee. And you've got a really good grasp on who your customer base is. Like, you've got a great predictor on what your customers want, and you know that some of them want tea and some of them want coffee. And let's just, let's say that's the only thing you sell. And suddenly media articles come out about your supplier for your tea, say, and there's something going on in the supply chain. There are some controversies. There's, people are outraged. And on the other hand, articles come out, as they do so often, about coffee. And, there might be articles about heart disease or other things about the particular coffee brand, maybe that you are supplying in your shop. And so a couple of fringe customers will switch their preferences between coffee and tea. But of course, none of these media articles are in your model. You might have in your model, the last 7 or 12 orders of this particular customer. They might have ratings on your website, things like that. That will be in your model. But this doesn't seem to influence their next decision because there is an outside change. And so if you kept using that model, this tiny area where this fringe population changes their mind because of this media influence is misclassified. And this is not the fault of your model. Yeah. Now, to be absolutely precise about this, we have to distinguish two cases here. We have to distinguish concept drift, which is when your data is still coming in right. Like, you still have the last 7 to 15, however many orders of your customer. You still have, maybe they log in some way, they sign in your shop, something like that. You have their arrival time that hasn't changed. Yeah. but their order still changes. Their preference has still changed. So your model is no longer accurate. That is different from when you have a case of what we call data drift, yeah, where something changes about the input to your model. So the example here could be something like if you have any kind of surveillance system and a sensor suddenly stops working or overheats, and instead of producing values between, say, 0 and 1, your sensor produces incredibly high values. So the moment you replace that sensor, your model will work as before, and it will still produce the results that you want. But with the sensor failing, the model could just go completely out of the window, and it just might not work while that is happening. And of course, this can happen in all sorts of ways, and has all sorts of nuance. So there's, I think, an important distinction to be made, because data drift is often more under your control, and it is easier for you to find and relieve data drift than concept drift. You can't necessarily do anything about the concepts, but you might be able to adapt your data to make your model work again. Now, with that in mind, let's have a look at these two examples. And the Wienermobile is a fairly typical example in some way of things that happen with people who put together marketing and cars. I think there is also I can't remember, like a taco mobile or something. I wonder whether that would be an example of concept drift. And similarly, if you look at the horse-drawn carriage and first fossil fuel powered and now, electric engine cars, one of these is surely concept drift. Yeah, the Wienermobile is not concept drift. The Wienermobile does not. It's a perfectly valid example of a car, and a perfectly valid example of what happens in special cases of cars, like advertising and so on. But it is not concept drift. It is an outlier. There is no gradual population of Wiener cars arising that become a very popular vehicle or anything. Whereas if you were a horse cart salesman and you did not catch the change, the preference of people for, first fuel-powered cars and then electric cars, you would be out of business. So that is an example of concept drift. And I think the important thing that is often subtly forgotten is that this is something where if you are the merchant, if you are the, say, horse cart merchant, you do not necessarily make your own horse carts. But in some cases, we, with our models, influence the world in a particular way. And there are various aspects to this, to the interplay between the concept that is drifting on the outside and the way our model behaves, that makes, if you will, the concept drift almost unavoidable. So the moment we use the model, we are actually accelerating the concept drift. And that is something that we need to be aware of. So first of all, we breed smarter mice. You may have heard of this, like if you have mousetraps and you kill all the dumb mice that fall for that bit of cheese that you put in your mousetraps, you'll breed two things. You'll maybe just breed mice that don't like cheese, but you will definitely breed mice that have some way of evading your traps. And similarly, if you think about fraud or intrusion detection, if you plug holes in your system with a detection system, with a prediction system, and so on, the bad actors won't stop. They will just find new ways. I think there was an announcement of a zero-day exploit in the Netgear router just the other day. These things happen. They're part of development. You can't develop the perfect system. And so as your system develops, and as your system in production sort of produces these predictions, it influences the actions of people on the outside that interact with it. And similarly, if you have recommendation engines or anything like it, the actions of your system can produce feedback loops. So for example, if you have a recommendation engine on a website and the recommendation engine starts recommending a particular product more often, then people are more likely to buy this product, even though they might not necessarily be interested in it, leading to this feedback cycle where the product gets recommended more often because it's sold more often. So it gets sold more often because it's recommended more often. And it might actually take up the spot of a product that has a higher revenue for you, has a higher profit margin for you as a vendor. But because it is stuck in this feedback loop, it gets shown instead of a product that might be more useful for the customer, as well as better for your business. And there is a darker side to this as well. If you think about the controversies around crime prediction, we have a limited number of police officers. If you send more police officers to where you expect crime to occur, you will arrest more people there, and you don't have enough people to go around elsewhere, especially if crime is unreported in other areas. And so your system appears self-evident and self-fulfilling and might not actually have the effect or the effectiveness that you were hoping for. And a more business-oriented, I think, aspect is that the most profitable systems are usually very, very complex systems. That is just a fact of life, because they are complex, therefore there is less competition, and so you'll be able, if you have the edge, to exploit it more, whereas systems with an easy entry and so on and so on and so on. But the problem is that the more complex your system is, the harder it is to make a model for it. So if you are, for example, trying to build a new credit product or any other kind of financial transaction system, say, the development of this system will take quite some time, months, if not longer than a year. So by the time you put this thing into production, it is way old. Your model starts aging the moment you stop collecting data. Yeah, that has the great disadvantage that complex systems are more fragile because they have more moving parts. So not only is your model old by the time it gets into production, it is more likely to get off the path, or well, the world is more likely to change in ways that you don't want. So you want to have a model that is as accurate as it can be for as long as it can be. If you look at the environments in which we see these models deployed, we can think about like three major sort of clusters or three major types of environments where these models are deployed. And they have different types of, or they are most likely to encounter specific types of concept drift. So if you think about monitoring and control, that could be something like computer security or financial transactions on the internet, as well as public transport, for example, or industrial monitoring. These systems are often very, very complicated, so they suffer from the complexity of the system. However, their concepts often drift very quickly, in the sense that if you think about transportation, for example, the knock-on effects from accidents in traffic are far-reaching. If you think about tram lines, which you can't easily divert, things like that, or the aforementioned zero-day exploits, or any kind of intrusion.
Okay.
Sorry? Kate? Hello?
All good, Eike. I think someone was just came off mute.
All right. Okay, thank you. Right, so where were we? Oh yeah, sudden change. Well, that was a sudden change. So these systems are often very complicated and have to deal with adversarial attacks. In computer security, in telecommunication, you could think of having a large telecommunications net and having people trying to access the net without paying for it, or fraud in financial transactions, and so on. The outcomes of these changes are usually unpredictable. You don't know what's going to happen. Like if you could predict traffic accidents, you could probably prevent them, and we can't, unfortunately, yet. Another area that models are often deployed is in information management. If you think about spam filters or customer profiling, recommendation engines, or the very popular and recent one is personalized learning. Yeah, the source of change here is usually something within a certain context or within certain preferences. Although I would say, if you think about spam filters, you could probably also think about it as adversarial. However, the speed with which the system in general changes is not as fast. For example, if you had a spam filter that somehow has a loophole that one or two bad actors identify, they are not necessarily going to change this, because that would inform and give an advantage or give away their advantage over the competition, and would it make it more likely and faster detectable. So a lot of these changes are, or if you think about personalized learning, the preferences for certain courses, there's a new technology coming out, and then more and more people are drifting towards that kind of learning or that kind of topic. Yeah, and so in some cases these are fairly predictable. If you know yourself, like if you're looking at personalized learning, for example, in an area where you are learning yourself, then this is fairly and this is fairly predictable. But in other cases, say spam or customer profiling or recommendation engines, the results could be unpredictable. And if we think about analytics and diagnostics, then we have a very current example. You could think about something like credit scores or demand prediction. Toilet paper comes to mind, but also something like drug resistance prediction. And the change here comes from the population itself. So either the population of, say, Australia, or the population of bacteria. So if your targets get the antibiotic resistance, for example, if the targets get resistant over time, this is an incremental change. It could be identifiable in the sense that you expect this to happen, you know this to happen, but you don't know the shape or time it's going to happen in. And then you could have changes that are reoccurring, such as Black Friday sales or Christmas sales. You might not exactly know when they happen again, but you can identify them. So for some reason, say a certain movie coming out, Frozen 3, something like that, could increase or sort of, if you predate, Christmas sales, right? But at the same time, you know more or less what's going to happen. Like, you know that you will have to deal with larger stock, different stock, and so on. So if you had a system that is trying to be active and predictive in that range, you could identify what's going to happen, but maybe not when or how. So that brings us to probably the most interesting question and the most simple answer. We can't do anything until we identify what's happening. Yeah. It's very important to know, as you've seen in the different areas that you experience these different kinds of drift, that you know what kind of drift you're dealing with and where it comes from, and therefore how to adapt to it. But how do you know? Like, what's the best way of finding out whether you're exposed to drift? Logging. You have to log absolutely everything. You log your inputs, you log the predictions of your model, and you log its performance, its accuracy, or whichever metric you use for performance, and you log the outcomes of those predictions, as said before, like the real-world results, if you have access to them. And then you compare that to your inputs and how they change and whether that is what you expected. And that is how you find concept drift versus data drift, for example. Yeah. If we remember what we've just seen, or what the table that we've looked at with the different types of drift and the different speeds, we can think of a couple of examples. The toilet paper mentioned in terms of sudden drift, that would be an example for a very quickly changing and sudden demand that you would have to adapt to. If you think about gradual drift, I don't know if you've been around in the 80s and 70s when the first Superman movie came out. Well, it probably wasn't the first one, it was my first Superman movie. But after that came Tim Burton's Batman, and then came Christopher Nolan's Batman, and the superhero movies picked up more and more and more. And now the biggest blockbusters are all superhero movies. Yeah. In terms of incremental drift, you could think about cars in a similar way to the movies. So you could say that incremental drift is maybe just a very, very fine-grained gradual drift. At the same time, I'm not fully convinced because with the movies, it's almost like a binary change. Like the types of movies that make the most money change to this one particular type from another type. Whereas with the cars, there is a definite drift towards a technology, but we don't know the exact outcomes. It could be that with the electricity revolution, there will also be other aspects of driving that have to change. And reoccurring context, as mentioned, that will be, for example, Christmas, Black Friday, Easter in some countries, and so on. Okay, let's have a look at what your model could look like, what could be on the ground, what could be working for you, and how this applies and what its effect would be, and how well it deals with the different types of change that we've identified before. And in terms of type of training, or should have probably written type of retraining, to be honest, we can think of two different ways. You could either have a warning, like a triggered sort of alarm going off. It's like, oh, we need to retrain now. This is happening. We need a new model. Or you could think about continuous training, where you have a system that updates and learns on the fly, like a machine learning pipeline. I have more to say about that later. Let's start with single models. If we think about triggered retraining in single models, we're talking about a certain threshold of something has been crossed, we've logged, and the results have changed. And we've decided, okay, it's no longer good enough. We need a new model. You need to get data from somewhere. You have to throw away your old data. That's no longer good. That gave you the money, the model that's now not working. The benefit is here that your collection window is variable. You might be able to collect quite a bit of data depending on the type of change, or the type of the amount of time that has passed as you look through your logs. You want to get as much good data as possible, so it might also be that you have to wait a little while. You might know that there is a change, but at the same time, as you develop your model, you realize the data is not good enough to get the same quality of model as you had before. So you might have to sit and just basically eat it for a while until you get enough good data so you can replace your model. If you continuously retrain, you have, say, a machine learning pipeline like mentioned before, and you have fixed windows in which you collect data. These windows can be various sizes, but what you can do is you can keep your data most recent, or you can increase the influence of the most recent data if you weight that data by age. So if we think about how this works in terms of the types of change, with the sudden change, the retraining, if you have enough data, is fairly cheap. It's a single model. It's probably recycling a whole bunch of the things that you've done when you implemented it in the first place. And a continuous machine learning pipeline is fairly easy to implement, actually. So you could have a system that is learning on the fly, and the change doesn't really have to bother you because it will adapt as fast as it can, as fast as any model can. Gradual change is ridiculously hard. For a single model to identify which data to train with and when to start training in sort of hindsight is really hard. And you will definitely incur some loss as you are progressing through the change, because your alarm has to go off first. So you have to, there will definitely be some aspects of that change that have passed without you noticing. And then you have to delve into your data and dig to find all the relevant points and separate the sort of not very useful data from the useful data. Incremental change is really, really, really hard to do similarly without continuous training. As the model progresses through with varying windows to the more recent and more recent and more recent data, it will just catch up as to what's happening with the incremental change. But with the trigger change, you will never know you will never know for sure when to start training. If it's an incremental change, you don't know where it's going. So you don't necessarily know what kind of data to give your model, and you don't want to waste any time, but you also don't want to waste any money and then have a continuous change and have to retrain again and basically have no, haven't gained anything because the world is still changing too fast. Retraining in case of recurrent systems is just way too wasteful. Why do it if you already know what's happening? And each time you have to retrain and identify the system, you would just lose money because you have to wait until you have enough data to retrain your system. So that is just not very, that's just not very useful. So more or less, in a tight package, if you have a single model, those are best suited for sudden drift situations. You get the best bang for the buck in those cases. Okay, so what if you have an ensemble model? What if you have a number of models that make your predictions, and what type of change and what type of training would work best together? So when I think about triggered retraining in terms of model ensembles, the easiest thing that comes to mind is the trigger activates a pre-trained model. You know what's coming, trigger goes off, model switches, you've collected data on the way as your model were running, and the model that is not in use at the moment can be retrained and then deployed the next time around. So that is, I guess you could think about it as a triggered continuous hybrid model, but it's not really, it's sort of semi-continuous, yeah, or I guess discretely continuous, oh, whatever. A really continuous retraining has basically a whole bunch of single models in your ensemble that get retrained continuously in a machine learning pipeline. On top of that, you have a voting system where your models are weighted by their accuracy on the outcome. So you have to have an expected outcome. You have to sort of want to know what you want to do with your system, and you have to kind of have a nested training or evaluation system for your ensemble where you say, okay, I am looking at the outcome of my model predictions, and I am giving those models basically a thumbs up that have predicted the situation correctly, and I'm reducing the weight of those that have been further away. And that way you have a flowing ensemble which gets votes on what the situation is. And so you have the combination of the retraining and switching as before. So if you look at the different types of change, retraining a model ensemble in case of a sudden change will be really expensive. Depending on what kind of model you use, you need a lot of data. So it's not going to be very fast, and it's probably not going to be very satisfying. Gradual and incremental changes, yeah. Continuous training, it's probably more, what's the word? I would again say satisfactory. It's probably more satisfactory than even a single model, than a single model in this case, because you have a much more flexible ensemble. And the recurrent change, again, is very, very easy because you can just switch to whatever state your system requires, and as you activate with the trigger, the moment you know that it's happening, you minimize the loss that you would incur otherwise from the delay. And so if you want to be prepared for gradual or incremental or recurring concept drift, you're better off using an ensemble. So depending on what environment you're in, deploy a different type of model if you're concerned about concept drift, depending on weight your concept drift concern, if you will, by the business criteria and the possible costs. And as I said before, log everything. It should now be clear why you have to log everything so that you can correctly identify what type of change you're facing and what type of drift you're facing. And I can only recommend, please watch the machine learning pipeline talk by my colleague Xin Liang if you are interested in any implementation of continuous training or continuous training pipelines. She knows way more about that than I ever will, I think. She's also continuously learning, that's why. And with that, we come back to our quiz. And I think, haha, that's 30 minutes on the dot. Perfect. Right. So please review your answers from before. I'll give you another 10 seconds to type your answers in the chat, and then I'll have a look, and then we'll go over to our question and answer session. Right. So, and the answer is cowboys versus dinosaurs. Alien versus Ninja is not a case of concept drift, because the aliens obviously already existed. They just happen to this time be on Earth, whereas the cowboys clearly missed the bus. Sorry, the dinosaurs missed the bus. The cowboys are a far further developed species, but on the same planet, and so they are the Ferrari, whereas the dinosaurs are the horse cart in comparison to the example that we had before. Thank you very much. So, and with that, I will head over to the chat and have a look. Aha, aha. Well, it would be interesting to hear questions around this, or if you want to have a discussion on why you think your answer is right. I would also love to hear your reasoning. Both movies are probably not worth watching. Like there are other ways to learn more about concept drift. I say that without having seen them, though. Do you have any questions besides that? If not, I will dive into explaining why I think Alien versus Ninja is not a concept drift film. Is there a risk of overfitting to a sudden change if there is a mean reversion after the shock to the underlying? If there is mean reversion after the shock to the underlying system disappears, I guess that's the point of logging the inputs predicting performance. I guess you could just retrain after the shock. Well, yeah, and that's a good question, because I wonder. People say, "Oh, the world has changed forever since COVID." And to be honest, in the case of, for example, toilet paper, I don't know. I wonder whether this is going to turn into a recurring event where people just, every time there is a sign of a new wave, they start panic buying. If every time there's a mention of a wave, they start panic buying, or whether people are now saturated with toilet paper. So for a while, that will influence their purchasing, and then things will return to normal until the next super virus comes out. Also, don't throw away your old model. Like, that's not, as Patrick once said, storage is cheap, confusion is expensive. So just keep all your old stuff, and you can still return to that and maybe just work based on that if whatever upset the market in that instance disappears. I hope that answers the question. If not, please let me know. I'll clarify. And with respect to Patrick's question, that is a good question. I don't think there is a simple answer to that, because it strongly depends on what you're looking at. So, for example, I wouldn't have thought that machine vision systems, like one of the things that are happening right now is we see facial identification systems that struggle with masks. Yeah, so that is definitely a concept drift thing, and I would say, I'm not gonna. Yeah, I think, to me at least, that was some kind of black swan. I wouldn't have seen that coming. I knew from people's predictions that people were afraid that a super bug was on the horizon, but I wouldn't have thought that masks would be a thing that I need to think about in terms of facial recognition systems, say. And that is now something that we have to adapt to in many cases. One could say, if you think about it in that regard, the more specialized your output, I guess, yeah, in a complex system, and people are certainly complex systems, the more fallible you are with, like, the more vulnerable you are in terms of concept drift. But at the same time, I wouldn't look at it as like what kind of machine learning problem you have there, because I think that depends on the system complexity in which you move. And I wouldn't consider that a type of machine learning problem. Does that answer make sense? I'm not sure whether I'm getting it across correctly. It feels to me, what businesses are the most susceptible? Well, I think the more, again, like the more complex your system. So for example, I would say the larger your business and the more complex your interactions. So let's say, I would say, for example, a gym, yeah, or even a chain of gyms that has an app and uses data science and so on, is probably less susceptible to concept drift. The concept drifts in that field, because it's fairly narrow, would be things like, I would imagine, new trends in terms of fitness or whatever. But I don't think that in terms of their business model or so on, that would necessarily have to adapt too much. Then again, they have to adapt to COVID just as we all do. But in terms of, yeah, that's exactly it. Yes. But businesses like banks have such a complex and wide network and are so interwoven in the economy and so on, that I think they are way more susceptible to concept drift than a gym, for example. Yeah, I'm not saying gyms are not susceptible to concept drift. I'm just trying to sort of get a gradient there, like sort of, yeah. I think like anything like banks, transport, logistics businesses, for example, anything like trains, Qantas, right? Complex businesses with huge, vast networks that are all relying on many, many levers that have to be pulled for them to work. The more levers there are, the more difficult it will be. Does that answer the question? Does that make sense? Mining companies. Good question. I don't know. I don't know enough about mining companies, I would say. At first glance, I would think probably not, but that might just be my heuristic bias, because I think banks are probably, together with transport and I would think Amazon maybe, and Google, anything IT, anything internet, they're probably at the top there. But that, oh, interesting. Could you elaborate on that, Marcus? Then again, keep in mind that Marcus also thought that Alien versus Ninja was, the concept of movie.
Always contentious. No, if you look at bank, they don't just work on one specific industry like natural resources. They have a lot of different clients. Whereas as a mining company, you depend on how quickly was this last shipment moved overseas, how quickly are new resources coming in. And all of these things influence prices. And they're quick and radical changes. And if you don't adapt to them, you will lose out on a lot of money. Whereas in banking, the business is more steady. Drifts do happen, but they're more slowly.
That's an interesting one. Because, yeah, it's the more of a thinking along the all your eggs in one basket kind of thing. Which is probably, yeah, if you go back to Patrick's first question and think about it in terms of machine learning problems, a bank is not a machine learning problem. It's a business. And so the business itself probably experiences drift in all sorts of ways and on all sorts of edges alongside its business, but it doesn't bring the business down. Yeah. So in that sense, it might experience more, but it might not be as vulnerable to it. That's right. Whereas if you have a single business, like a single gym, for example, or that mining business, and they do not adapt, like if they still use horses, seahorses, obviously, to draw their carriages across the sea, and they don't adapt to say petrol fuels, or now what's going to be the next thing? Is it going to be electric, or is it going to be sailing ships again?
Hydrogen.
Hydro. Okay, so water coming in at the front and going out at the back. Yeah, if they don't adapt, you're right. They will be quite vulnerable. Yeah, and it might be not just speed and delivery and so on. It might also be demands from stakeholders, shareholders. It might be fines from countries they deal with if they have ships that do not, I would imagine, stand up to certain standards that various ports might impose on them. Might become more costly. Yeah. Mm-hmm. Yeah, it's interesting to see where and how interwoven this whole thing is with business itself, because that seems to be halfway between a business problem, like a sort of knowing your market and knowing your area, and machine learning problem. Are there any other questions? Let me see. That looks like the. Oh yeah. What about NLP? I think the ML tools doing copywriting and grammar work all wrong when COVID hit. These are not necessarily part of complex business. Basic copy and add headlines, but the approach to the market was totally off. That is, yes, that is right. And I would expect the big tools like Google and Amazon to now catch up. But if you think about chatbots that are developed for particular clients in particular situations, just to further harp on the bank, those situations might be not suited to the question, although those systems, might not be suited to the questions that people are asking. Similarly, if you had a hospital chatbot or any kind of medical insurance chatbot, they might be rather challenged or simply out of their depth if they have to answer questions about COVID without having been trained on any of that material. Yeah. Mm-hmm. Do we have any other questions? Is fraud so? Totally, absolutely, yeah. Breeding clever mice. I don't know when you joined the talk. So we did talk about that before. So if you think about let's say you make a fraud detection system in a financial transaction space, let's say some kind of escrow. Let's say you work with, say, PayPal, yeah, and you plug a bunch of holes where people can then, thanks to your new model, no longer defraud the company. It's very unlikely that you have made the perfect system and there are no more holes. People will find other ways to defraud the company and steal the money. So that is literally the concept drift, and that is literally the problem that any kind of criminal investigations, I think, have to deal with, is that the bad actors will just adapt to the system and to the new reality and still try and get through. So I guess the main, this is going to become a whole other political thing. Like if only we gave everyone enough money, then they wouldn't have to steal any, and then they would stop. Oh well, but I think that's the problem. Like the bad actors will adapt, and they will just change their MO. They won't leave the money where it is just because it. Yeah, I think that's a phenomenon that you see in many places. That's probably not just fraud. Does that answer the question? Ah, fantastic. Right. What time is it? We've got, oh, it's 10 to 1. So if you don't have any further questions, I'm going to thank you for participating and coming to our virtual brown bag. And I don't know yet what the next one's going to be, but I'm going to invite you to it all the same. Please keep your eyes and ears open as to what we're going to do next in this space. Thank you very much. Stay safe. Wash your hands. We love you.